Hi everyone, I'm making another video on pressure because the earlier one I had made did not have the sound come across, so hopefully this one should work. So this is just going over pressure. So what is pressure? Pressure has to do with the amount of force that acts over a unit area, and the symbol for pressure is the letter P. And pressure is measured in 2 units, and the units in which pressure is measured is called Pascal, that's 1 unit, and the other unit is Newton per meter squared, and I'll explain why it's got these 2 units. So the formula for pressure is pressure is equal to force that acts upon a particular area, or it's force divided by area. And using this in symbol form, pressure is equal to P is equal to F divided by A. So that's a formula for pressure. Now, force is measured in newtons. Area is measured in meters squared. So when you divide newtons by meters squared, you get Newton per meter squared. So that's where you have this unit for pressure. And the other one is Pascal. So that's how you spell the word, okay? But it's written as PA. So that's what it is. It's just named after a scientist. So the rest of this lesson, I'm just going to look at some applications of pressure, why it's so important that we are learning about this topic. So let's talk about going to the beach, sandy beach, and the sort of shoes you're going to choose to wear is going to be flat shoes, okay? Because no one's going to go to a beach wearing stilettos, and I have here a pair of stilettos, and you wonder why it's not so smart to walk on a sandy beach or even on snowy ground with a pair of stilettos. And it all has to do with pressure. So it's the same person, it's me, at one point wearing flat shoes where the soles of the shoes have got a larger area in contact with the ground, as opposed to stilettos where the area of the sole is much less that's acting on the ground, okay? So what happens is that when the area in contact reduces, so just looking at this, so for a stiletto, the area of the sole in contact with the ground is less. It's the same me, it's the same person, so the force is the same. So when the area becomes less, the pressure exerted becomes more, and you're going to be sinking down, okay? So these are your flat-soled shoes, okay? And these are your stilettos. So the area in contact for the flat-soled shoes is all this and all that. For the stilettos is just this little point and a little bit there. So when the area is less, the pressure increases. That also explains why it's easier to cut something with a sharp knife as opposed to a blunt knife. Now that is, so you need the same amount of pressure to cut it. However, when you have a blunt knife, the area is bigger, so you have to apply much more force in order to get the same pressure to cut it. But if your knife is sharp, and a sharp blade occupies a very small area, however, the pressure you need is the same, so you need less force. Okay, so we'll also talk about that with this experiment I have with the 2 balloons here. Just put these away. So I have got these 2 balloons, okay, and I need the same amount of pressure to burst it. So there are many ways I can burst a balloon. So one of them is taking a pin that's really sharp, a single pin. So where's the camera? There you go. It's just a little pin. And in order to burst this balloon, I'm just going to poke it. Oops, did you hear that sound? Okay. And that's one way I could burst the balloon. But I could also choose to burst this balloon using a bed of nails. So I've got a nail bed here, which was made specifically for this experiment. This has got hundreds and hundreds of nails, and the nails are just as sharp as the pin. So now I'm going to put the balloon in this nail bed between the nails, and I'm just going to lower the camera so you can see what I'm doing. Okay, there we go. Okay, so this is on the nail bed, and I can move this thing up and down in order to burst the balloon. So the balloon's sitting on all these nails, on a bed of nails, and I'm going to try and burst the balloon by pushing it down. So can you see I'm using both hands? The other one I just had to poke it slightly with a single pin. So it takes a lot more force in order to get the same amount of pressure to break the balloon, and it's really hard. Oops, still not burning. There. Gosh, I hope that wasn't too loud for you on the camera. It was really loud in the room.